The annoying part about partial failures is that they never show up as clean outages. One service is fine, one shard is melting, and the user just sees something is slow, like that's supposed to help. I'd rather classify them early: timeout, degraded dependency, data inconsistency, or a dead instance pretending to be alive.
Yeah, because it works on my machine is apparently a monitoring strategy now.
Exactly. Heartbeats only tell you the box exists, not that it's actually useful. I like combining liveness, latency percentiles, and error budgets. If P99 jumps but success rate stays high, that's usually a warning that one region or downstream is wobbling, not a full collapse.
So basically, the system is lying politely.
Constantly. And the trick is detecting the shape of the failure before it spreads. A queue backing up is different from a dependency timing out, which is different from a split brain. If you classify them wrong, you page the wrong team and waste 20 minutes while production catches fire in the background.
I'm guessing you have a scar story for that.
2, actually. One involved a cache that was healthy for 6 hours while serving stale data. The other was a retry storm that looked like good traffic until we checked the downstream. The logs had the confidence of a toddler with marker on the wall. Once you can detect the partial failure, the next question is whether you should touch it at all. Timeouts are the first line of defense, but they need to be tight enough to stop hanging requests, and loose enough not to punish a slow but healthy dependency.
Which is the fun part, because setting them wrong just makes everyone unhappy faster.
Exactly. Then retries make it worse if you're careless. A retry is not a fix. It's a bet that the next attempt has a better chance. If the failure is persistent, blind retries just amplify load. That's how a small outage becomes a full one.
So you're saying, try again, is not always optimism.
It's often denial. That's why exponential backoff matters. You give the system breathing room, and ideally add jitter so every client doesn't wake up and stampede the same dependency at once. Without that, you get a synchronized herd of little disasters.
I've seen that. It looked less like software and more like traffic on a bad highway.
And the cleanest setup is to pair retries with a circuit breaker, or at least a failure budget. If the dependency keeps timing out, stop pretending it'll recover on the 4th identical attempt. Right. And that's where circuit breakers earn their keep. If a dependency is clearly sick, you stop sending traffic for a while instead of hammering it into dust. Half-open probes are the interesting part. 1 or 2 careful requests to see if it's actually recovering.
So it's basically the software version of I'm not mad, I'm just disappointed.
More like I'm not letting you near the kitchen until you can hold a spoon. And bulkheads are the other half of that story. You isolate resources so one broken area doesn't sink the whole ship. Separate thread pools, separate queues, separate limits per tenant if you're feeling generous and not under a deadline.
Which, to be fair, is never.
Usually not. But without bulkheads, one noisy service can starve everything else. Then you get a cascade, and suddenly the checkout flow dies because some reporting job decided to become ambitious.
I do like the idea of containing the mess. It feels less heroic and more survivable.
That's the point. Distributed systems reward containment, not bravery. You want failures to stay small, loud, and boring. Containment only works if you can safely try things again, and that's where idempotency saves you from your own retry logic. If a request can be repeated without changing the outcome, life gets a lot easier.
Except when someone forgets to make it idempotent, and then the same payment goes through twice.
Exactly. The classic disaster. Without duplicate handling, retries turn into side effects. Double charges, duplicated messages, repeated writes. The system doesn't care that the user only clicked once. It just sees attempts.
Charming girls. So we need request IDs everywhere.
Preferably, yes. A client-generated key or a server-issued token lets you recognize duplicates and return the original result instead of doing the work again. You also have to think about storage windows, because idempotency isn't magic if the dedupe entry expires too soon.
Right, because the universe loves a timing edge case.
It does. And the tricky part is making idempotency hold across partial failures. A request might time out after the write succeeded, so the client retries. If you can't detect that as the same operation, you've got a ghost duplicate and a very annoyed customer. That kind of ghost duplicate is exactly why failover needs discipline. Once you have multiple nodes, someone has to be the leader. And if that role changes carelessly, you get split decisions and conflicting rights.
So leader election is basically the part where everyone pretends not to want the job.
Pretty much. The problem is choosing a leader fast enough to recover, but not so fast that transient network noise causes a coup. If a node pauses for GC, or loses a few heartbeats, you don't want the whole cluster to panic and elect 3 leaders before lunch.
That sounds weirdly relatable.
The better systems use leases, quorum checks, and fencing tokens so only the current leader can act on shared state. Failover should be boring. Detect loss, confirm it, promote one node, and make sure the old leader can't keep writing if it wakes up confused.
Because zombie leader is not a title you want in production.
Exactly. And the ugly truth is failover is never just about picking a new leader. It's about making sure the old one is actually stopped, the state is current enough, and the clients know where to go next without thrashing around like they lost their map.